So next one, this is another example of solar radiation. So basically the example is quite almost the same, but now they are quite different because they have the material here. Find the total radiation for vertical surface, which is the material is red brick here, and at Bandar Baru Bangi. The time is 4 p.m. Bandar Baru Bangi facing south 60° west on 21st of September. So, in front of the surface is a horizontal concrete. So, this is the question will be referred to reflection. So, since it is it given horizontal concrete floor, so given also here will be the GTH, 1500 BTU hour feet square. So we have to find the solar time as previously same. We have to find the T sol first. The time given is 16 or 4 p.m. 120 is same, constant. For Malaysia is 120 degree. And location from the table 101 degree 14 minutes. Time 4. ET is equation of time. So we get the T sol is 14.55. So the next one we have to find the hour of angle. H is equal to T sol minus 12 or 12 minus T sol. But this is more than 12, so I believe you should know it is 14.55 minus 12. So 2 hours and 55 minutes. So how to find 0.91 here? 2.91, 55 divided by 60, and then you get 2.91, 6 hours times 15 degree. This is constant, 43.75. Alright. Next one, we find the solar altitude angle of beta. So beta, sin beta is cos L, is from the table for Bandar Baru Bangi, right? And then the cos H is previously from the calculation. Cos alpha is from the table, which is in the month of, this is in the month of September. So look into the table in the month of September, and then the declination degree of alpha, declination degree is 0.0. So which is cos 0 here, cos L is same, sin declination sin alpha is 0 here. So shift sin the beta, so the beta value 46.17 here. So next one we have to find the solar azimuth angle of phi. Cos phi sin beta is from the table, from the calculation, previous calculation. L is from the table. This is the latitude. And then sin alpha is the declination degree. Here cos 46.17, 2 degree 46 minutes, and then you get the answer of 86.56 or minutes. Right. So after we finish the solar azimuth angle, next one we're going to calculate the angle of incident here. So the formula is cos theta equal to cos beta from the previous calculation of beta here, cos gamma here. So we have to find the gamma value first. Gamma value, the phi value is 86.56, and then minus 6. Either we want plus or minus the 6. Minus or plus or minus the lambda value. So as usual, we have to calculate from the south value. So this is evening, so we have to calculate from here to here. So the value of phi is here, 86.56. So 86.56 is here. So the lambda value will be also from the south value. So it is located inside the phi value here. So this is 60. So this is the value of gamma that we are going to calculate. So the value of gamma is 26. That's why we have to minus 86.56 minus 16, because we want to find the lambda value here. Cos theta equal to cos beta from the table, from the previous calculation, and then the gamma here, the value here put. And then you get the angle of incident is 51.87 degree here, right? This is the value of angle of incident. So next one, Same like previous, we have to calculate the direct normal radiation. So the A is from the table here. This is the month of, the value of A is here. So this is our example is in the month of September here, right? So the value of September is here. Wait a minute, right. So this is the month of September, 360. So this is the value of A, B, C, and 360.2, 0.165, 0.121. Right. So the value of A is 360.2 here. Exponent value, this is the B value, 0.169, 0.165, and then the sine beta is from the previous calculation. So you get the answer of GND here. Right, the next one is to find the GD. GND value put here, and then the cos theta is from the here, the angle of incident here, 51.87 degree. Right, so you find the direct radiation. Then you have to find the diffuse radiation, GD. So the value of C is from the table of C. You have to find the C. This is A, B, C. So the C value is 0.121 of September, right? Times GND. So GND value will be put here. You get the answer of diffuse radiation is 34.674 BTU. Alright, the next one, this is another that we add in this question is total reflected radiation, or GR. So GR value, the GTH is given in the question, which is 300 BTU hour. Right. So usually during the example of written, we will give the value of GTH, because GTH will be referred to another table, but somehow it is too many, so that's why we will just give you the value of GTH. Alright, so we have to find the FWG. So this is the value referred to the material. So you have to refer to your formula and appendix table. So we have to find FWG, 1 minus cos sum of divided by 2. So divide by, this is the value of 90 minus alpha, which is the alpha is 0 because it is horizontal surface reflected. So since it is horizontal surface reflected, we have to use the alpha of 0. But if it is vertical surface reflected, we will use the 90 minus 90. So that's why the value of sum will be 0. But in this case of vertical, but since this is the vertical, the case of horizontal, since it is vertical of floor, horizontal floor, that's why we are using the 0 value here. Alright, so FWG here you get is 0.5. So the formula is GR, 300 is given, times 0.45. So how to find the value of 0.45? So using the formula of appendix here, wait a minute. The value of 0.45 here, refer to appendix C, page 14 here, right? So the value is the material is red brick here. So red brick, and it is doesn't have the angle, incident of angle is same, either what is the incident of angle. So since it is 0.45, so you have to refer 0.45. So, but somehow you have to refer the angle of incident, like previously we have calculated here. So this is the value of red brick, 0.45. Same for every single angle of incident here, right? So the angle of incident is 0.45. So that's why you got the value of GR here, 67.5. Right. So the last one will be the total solar radiation. Since we have calculated the GD, which is the direct radiation, diffuse radiation, and GR is reflected one. So just add all of the value of GD, the diffuse, direct, and GR reflected, you get the answer of total solar radiation, which is 279.114 BTU over our feet square. Please don't forget to put the value of and the unit. Alright, so this is until the solar radiation calculation. Thank you very much and see you for the next lecture. Assalamualaikum.